Hello students! In this video we are going to be learning to use and love the law of cosines. So previously you have learned about the Pythagorean theorem, and you know that if it's a right triangle and you're missing one of the sides, you can use the Pythagorean theorem to find the missing side. Well, what if it is not a right triangle? The law of cosines will allow us to find the missing information for triangles that are not right triangles, that are oblique triangles instead. So here's the law of cosines, and it feels familiar. C squared equals A squared plus B squared minus 2AB cosine C. So please notice that that's a capital C here for the angle. This is the only angle in the problem, whereas these A, B, and C here are sides. So when do we use the law of cosine? In order to use the law of cosine, you need to be given information that is either side, angle side, or side, side, side. And in a second we'll do example of both of those scenarios. In order to start with the law of cosine, the first thing that you need to do is relabel, no matter what numbers are giving you, label what you're going to plug in. What am I going to plug in for A? What am I going to plug in for B? That sort of thing. So as you're plugging in things, I would suggest that you start with C, since C is the only angle. So if they only give you one angle, then that's the thing that you're going to plug in for C, which means that right across from that angle would be the lowercase c, the side that you don't know. Okay, and then the other two can be A or B, and it does not matter which number you plug in for A and which number you plug in for B. It doesn't matter. Okay, but the C has to be the one that matches, that's right opposite from the angle. Okay, or it could look like this, where you're given all sides. If you're just given all sides, then it doesn't really matter which one you let be A, B, and C. Let's say that this one is A, this one is B, and this one is C. Okay? You're just going to pick which ones you're going to plug in for A, B, and C, but the C has to be the angle that is opposite from side C. So this is the capital C now that we're finding. Why is that the angle? Because that's the one that's opposite from the C. And if I would have mixed them up differently, then C would have landed in a different spot. Okay, what about here? This one, it looks like the capital C is going to be the angle that I have, okay? And which means that the lowercase c would be over here, and it doesn't matter which one you let be A and B, we'll just say A, B. But if it looks like this, where you already know the side and the angle that are opposite each other, you already know them, then don't even bother with the law of cosines. If you have those, then you should use the law of sines. So this one is side, side, angle. So with side, side, angle, you should use the law of sines instead. But with side, 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 or side, angle, side, we are going to use the law of cosines. So let's look at an example of using the law of cosines. So in order to solve this triangle, the first thing I do is I classify the triangle. Oh, looks like it's not a right triangle. So since it's not a right triangle, let's see what I have. They gave me a side, an angle, and a side. Since they're in that order, side, angle, side, I need to use my cosine law. So I remember the cosine law is, okay, go ahead and write it out. So now I need to figure out what numbers to plug into here. So I know that this capital C here is my angle, so that's going to have to be this here, capital C. Then the other two sides are going to be my A and B, and it doesn't matter which is which. I'm going to let this be my lowercase a and my lowercase b, which means that this side over here must be C. So let's go ahead and plug in. So I don't know, C equals A is 20, B is 30, minus 2 times 20 times 30 times the cosine of 60. C squared is equal to 20 squared is 400, 30 squared 900, and 2 times 20 times 30, 1200. A common mistake from here when people are solving this is to as the next step say, what's 400 plus 900 minus 1200, and combine all three of those. However, the three of those do not combine because the 1200 is multiplied to the cosine 60. So you need to handle this multiplication separately. You cannot subtract it from the other numbers yet, right? The 1200 is attached here, so it's not like terms with these two. Okay, so the cosine of 6. So let's use our calculators now and find that the cosine of 60 is 1/2. So we have 1300 minus 600 gives us 700. Then taking the square root is 26.5. Now we have found all three sides. We also need to find all three angles because they asked us to solve the triangle. So to continue, we need to find one of the angles. Let's find this angle down here next. To find the angle, let's use the sine rule because now we have a pair of things that are opposite from each other. So that's going to allow me to set up the sine rule with 26.5 over sine 60 equals 20 over, and the 20 matches with this corner. I don't know what it is. I'll just call it z. Okay, so let's cross multiply to solve. Okay, so solving for z, I cross multiplied, then I divided by 26.5, and then I put that part in the calculator and I got 0.6536. Just take the inverse sign of that to get z, and that gives us z as 40.8. Remember that when we're finding this sign that we can have two possible values for our answer. So we need to subtract from 180 to see what the other possible value is. Okay, so is 139.2 an acceptable answer for z? Could this angle in here be 139? Uh-oh. It looks like if this was 139, the two values add to more than 180. Then there would be no third possible corner. Triangles have to add to 180 exactly. So 139 is not a possible solution for this triangle. Is that z equals 40.8. I can finish by just subtracting from 180. Okay, so y equals 79.2. Let's look at one more example. This time I have all sides, but I don't have any angles. Alright, since I don't have any angles, I'm going to have to find all three of them. Let's pick which angle we want to find first. Okay, so first let's find this angle, but it doesn't matter. I could have let any of them be the angle I was finding. If this is my capital C, this is my lowercase c, and we'll let the other sides be A and B. Alright, so let's go ahead. First, remember your cosine rule, and now we're going to plug into it. Alright, so plugging in gives us 6 squared equals 9 squared plus 4 squared minus 2 times 9 times 4 cosine C. So simplify. 81 plus 16 gives us 97 minus 97 to the other side gives us negative 61. Common mistake people make when solving this is to forget the negative sign that's in front of the 72. Don't forget to bring that along with it, so that when you divide both sides by 72, you're going to divide by negative 72, and you're going to get a positive number over here. It's 0.84. Now we take the inverse cosine, and rounding to the nearest angle, we have 32 degrees for C. So now that we know the 32 and the 6, we have a pair. Okay, let's go ahead and use the sine rule to find either of the missing corners. Let's find this one. And we'll cross multiply. Alright, and 4 sine 32 divided by 6 gives us 35 point. Taking the inverse sine of that, approximately 21. Subtracting from 180 gives us the other possible value of 159, but that would not make a full triangle with the 32. So it must be 21 degrees here, and subtracting to find the other corner gives us, and that is cosine law.